Okay, section 2.1 is the rectangular coordinate system. 2.2 is graphs of equations. We're supposed to finish both of these in one day. I don't think we'll make it. But anything that you already know, I'm not going to do an example just like it. You need to know all the boldface terminology on page 82. Ideally, you could take all those boldface words and just write your own paragraph with them, because you understand that when you cross a horizontal line, number line with a vertical number line, you get the Cartesian coordinate system, named for Rene Descartes, who came up with it. But the point where the two lines cross is called the origin. That horizontal number line is called the x-axis. The vertical number line is called the y-axis. The two axes divide the plane. A plane is just two-dimensional space. If you imagine the chalkboard going forever left and right, forever up and down, that's a plane. The two axes divide the planes up into 4 sections. We call the sections quadrants, and they're numbered starting in the top right quadrant and counting counterclockwise. We start in that top right quadrant because that's where the x's and the y's are both positive. Any ordered pair consists of 2 coordinates. Those 2 coordinates tell you where you are relative to the x and the y axis. So in the first quadrant, since you've gone to the right, the x's are positive, and since you've gone up, the y's are positive. That's your ordered pair that names the point 5, 2. That's probably all the boldface words up here. But just make sure that you understand what all those mean. The 2 things that we did not do in college algebra, just for lack of time, we didn't do any problems involving the distance formula and the midpoint formula. So those are the 2 things that I've given you in the notes. Now that distance formula, I want you to understand why it is what it is, because it will help you remember it. Let's say in the Cartesian coordinate system, I have 2 ordered pairs. Let's call them x1, y1 is one ordered pair, and x2, y2 is another ordered pair. Let's say I want to find the distance between those 2 points, and we'll call that distance d. If you think about what you know from geometry, you could form a right triangle by drawing a horizontal line from that first point to directly under the second point, and then dropping down a vertical line. You've got a right triangle there. What's the most famous thing that you know about right triangles? Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. How could you get this, the length of this leg? Given these 2 points, how could you find that horizontal distance? I'm sorry, I can't count the blocks. But I didn't use blocks. You absolutely could. If I go from x1 over to x2, just subtract x2 minus x1, and it'll give you that horizontal distance. What will give me that vertical distance? Subtracting the y's, y2 minus y1. So this is the length of one leg, this is the length of another leg, and the Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared, and we call the length of our hypotenuse d, so I'm just going to say d squared. That's just the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. And if we think about what we were originally looking for here, the distance between those 2 points, that's just d. How do we solve this for d? That's the only thing we'd have to do to have just plain old D there. And that's the distance formula. D is the square root of the difference in the x's squared plus the difference in the y squared, because without that radical, that's just leg squared plus leg squared equals hypotenuse squared. You had to take the square root to get the hypotenuse by itself. You liked that, didn't you? Hey, that's where the distance formula comes from. You have, actually, we did use the distance formula in college algebra, but the only extent to which we used it is I gave you 2 points. You just plugged the two ordered pairs into the formula and told me what the distance was. We didn't do anything different with it. Examples 1, 2, and 3 in the book are like that. Example 1 just says, where is it? Here are 2 points. Find the distance. Just plug the coordinates into the formula and boom, that distance is square root of 89. If I ask for the exact answer, if I ask for a decimal approximation rounded to 2 decimal places, it's 9.43. All right. Example 2 is just like the example that we're about to do. So you'll have 2 good examples of this when you start these homework problems. But this says show that the triangle ABC is a right triangle. Well, if it's a right triangle, it has to make the Pythagorean theorem true. So I would plot those 3 points and say, if it is a right triangle, where does it look like the right angle is? Well, they've done that in the book. Here's A, here's B, here's C. If that is a right triangle, where does it look like the, at which vertex does it look like the right angle would be? It looks like it's right here. So you could find the distance from A to C and the distance from B to C, and that squared plus that squared would have to equal that squared. All right, it's just a matter of using the distance formula 3 times and then showing this squared plus this squared would equal that squared. Actually, that is exactly number 16 in the on the handout. I'm going to say in the homework you have one with those exact directions. Just read example 2 and do the problem in the homework just like yet. Number 22 says show that the point 77 is on the perpendicular bisector of line segment AB for these 2 ordered pairs A and B. When I don't know what else to do, I just draw a picture and see if that helps me. I'm just going to draw AB and then see if I can figure out what perpendicular bisector means and how the heck to answer that question. All right. Actually, it's exactly like example 3. So let's just look at it in the book. Example 3. They've plotted the point A and the point B. And what do you think the word bisector means? That line L has to go through the midpoint. So we could find the midpoint of that line, but it also says perpendicular bisector. That means not only does it go through the midpoint, but it has to form a right angle. Example 3 says there are 2 ways to prove that a point is on the perpendicular bisector to the line segment of the other 2 points. This condition 2 is the easiest one to show. You just show that the distance from A to C is the same as the distance from B to C. If the distance from A to C is the same as the distance from B to C, then C is on the perpendicular bisector of the line segment AB. So that's just using the distance formula twice. And then 28, there's not an example just like the book, so I want to do it. Find all points on the x-axis that are a distance 5 from the point -2, 4. College algebra was very much monkey see, monkey do. I'm going to show you a problem, you do 5 just like it. This, you have to figure out what the heck am I given and what am I actually looking for. And if you're completely stumped, draw a picture and see if that helps. The point -2, 4 is about here. I'll give you 1 point on the test for that. I'm kidding, I won't give you anything on the test for that. Can you guess where the points that are 5 units from that point are if they're on the x-axis? Wait, you're saying +3, 4. You're saying there's a point, oh, 3, 4 isn't on the x-axis. I've got to have a point that's on the x-axis.
Oh, 3, 0.
All right, so somewhere over here, there's a point where the distance is 5. And you're guessing that it's 3, 0, but I'm not totally sure of that
I'm
yet.
sorry, I was guessing.
Right, you were guessing horizontal distance instead of diagonal distance. But there is going to be a point over here where this distance is 5 as well. So we're looking for 2 points that are a diagonal distance of 5 units from that point -2, 4. And I've about run out of ideas. That's, this is not a right triangle. So, yes, that's exactly what I'm going to do with the distance formula. But what do I have that I can plug into the distance formula? I could take, what do I know about these 2 points? Is there anything I know about those 2 points? They're on the same line, and specifically they're on the x-axis, which tells me what about those 2 ordered pairs? What? Well, this, and 0. The y is 0 if you're sitting on the x-axis. So here's some, let's say, here's some first x whose y is 0 will give me that point, and some second x whose y is 0 will give me that point. To use the distance formula, I have to know 2 of 3 things. I have to know, the 3 things are the 2 ordered pairs and the distance. Well, I have 1 ordered pair, I have a half of ordered pair, and I have a distance. I think I could plug those 3 things into the distance formula. D is the square root of x2 minus x1 squared plus y2 minus y1 squared. What can I put in place of the d? 5, because that's what I want the distance to be. 5 is the square root of, what would x2 minus x1? I need to be careful using x2 and x1. That's what I've labeled these 2 points. But really, I'm talking about point P and one of the points on the x-axis. If I use point P and one of the points on the x-axis, then what's the difference in the x's? And I'm glad you said minus and negative. I'm going to go ahead and just write it as plus to save myself a step. The difference in the x's would be x2 plus 2, and that needs to be squared. And the difference in the y's would be what? 0 minus 4. Does it matter whether I say 0 minus 4 or 4 minus 0? It does until I square it. When I square it, it won't matter in which order I subtract it. because positive 4 squared is 16 and negative 4 squared is 16. So I'm solving an equation that only has one variable in it. I can solve that for x2. First thing I do is square both sides to get rid of the radical. Left-hand side's 25, right-hand side's x2 plus 2 squared, and just plus 16. And then what? That would give me 9 equals x2 plus 2 squared. And as soon as you said take the square root of both sides, bells and whistles went off in my head to remind me, don't forget the positive or negative. When you take the square root of both sides, don't forget the plus or minus 3 equals x2 plus 2. So x2 equals negative 2 plus or minus 3. That means one of my ordered pairs, the x is negative 2 plus 3, which is 1. And the other ordered pair, the x is negative 2 minus 3, which is negative 5.
Yes.
You could guess. I think it's close to 1. I think it's close to negative 5, but we found out for sure the x's are 1 and negative 5. And how would I find the y's? Yeah, we know it's on the x-axis, so y is 0. I know, it wasn't bad. All right, we will start tomorrow with the midpoint formula. You don't have to start the 2.1 homework yet, but I'll take up the 1.6, 1 through 49 odd tomorrow morning.